Hello everyone, hope you all are doing well at your end. Welcome to day 4 of pre-hackathon speaker session. The Python week is hosting live workshops, talk, discussion, and of course an amazing virtual hackathon. Everything just from 1st Jan till 10th of Jan. Now, moving to the speaker session for today. So, in this session, you will learn about machine learning basics, application of machine learning, case study, recommendation system. And with that being said, let me introduce you to all for the speaker for this session. We have Abhishek Nandy joining us. He is an Intel certified One API instructor, Intel Black Belt developer, as well as Intel Software Innovator. He has a keen interest in AI, IoT, and game development. We welcome you, Abhishek, and looking forward to your talk. The virtual stage is all yours.
Yeah, thank you, Tushar. Welcome all for this particular session. So about me, Tushar has given the instruction. Without wasting more time, I would start my session. So moreover, because before starting, I would like to tell you certain things because machine learning is a buzzword nowadays, but we have to know how exactly it works. So for this particular session would be on how the data science has evolved, what are the things that are there for machine learning, how do you take your ideas to the idea to the particular stage that when you can start working with it. So let's begin. So is my screen visible to all of you?
Yes, Abhishek, can you turn on your camera?
Okay,
Like,
just a minute. Yeah.
yeah,
Okay.
yeah.
Okay. So let's begin. So first touching up on the basics of data science, and then we will move on to machine learning. So let's start with what exactly data science means. So nowadays, like when we stress upon this particular subject, we have a plethora of information coming in. But if you want to break it down, we have processes, and from those processes we have to extract knowledge, and when we are extracting knowledge we have to get some insights in the various form, either structured or unstructured. So what happens when a data comes to you, when you try to gather information about data, it comes in either an ordered format or inordered format. So there might be some metadata that's already there into the data that you have collected, or it might not be there. So we have to get that particular data structured, and we are studying the insights into it. What we can say is we have got into the science of data. So that is known as data science. So moving on, how hot is the market? So if we just check upon the acquisitions that are happening for different kind of companies, like now we have the Dialogflow that has been already acquired by Google, and we have Nirvana Systems that has been acquired by Intel itself. So these are the companies that are doing work, and their work is getting famous, and acquisitions are happening. So if you have an idea that is related to artificial intelligence, and you know that you are solving a problem in a particular region, you would be aware that people are keeping an eye on you. So acquisitions happen with this. So if you have time, work together as a team and bring that idea to life. So the market is wide open. You have a lot of opportunities. Now there is a big question about how to become a data scientist. So that's not a thumb rule that you have to know about mathematics and other subjects, but there are different branches that come up with data science. So maths is an integral part, but there is a role for a storyteller. So if you're building an application, you have to bring on the story that is evolved with the problem solving. So if you say like, I am trying to do some work in agricultural sector, what you can say is like, I am doing some study on plant diseases. So that's an like an idea that can be directly implemented with deep learning. So how do you go about? There are different kind of frameworks that you can take advantage of, like TensorFlow, PyTorch, and we go to the object recognition thing. So what we will do, we will have to go back and we will have to find a person who knows about different kind of plant diseases, and we have to identify those plant diseases, and we collect images of different kind of plant diseases. When we start collecting this information, we need a very good storyteller. So storyteller is as well as important part in machine learning, because it is the ground basis of what you are doing. Now you have the entire data. Now you go to your the management. So how do you show it? There comes the part of visualization. You have to visualize the data in different form, like d3.js or any other library that is there, and you can get started. Now there is one important word over here, that is hacker mindset. So if you go to Kaggle, there are a lot of codes that are available, but those codes need a little bit of tweak when it comes to your idea to implementation phase. Take that code and you start getting inside the code and start to modify it. So hacker mindset is also required. We know that different kind of data needs to be read. So there comes an underlying story of working with either the queries, then we have NoSQL databases. That's the story of it. Neural networks is the basis, because when we start unraveling neural networks, we can distinguish between machine learning and deep learning. So you should have the passion for the data, and you have to know how the things work with data. You If you are engulfed in all of these particular fields or the words that are there, you are good to become a data scientist. Okay. Now the entire data science process. So the entire data science process is a bit of lengthy one, because firstly we collect the data. If we don't have any data in our hand, how do we go about doing data science into it? So the first step is the raw data is getting collected, then we collect the data and process the data. So when we have some kind of information, what we do is, like in the form of an Excel sheet or in a CSV, we have columns created and we redefine. Say when we are trying to find out the iris data set, what we have the sepals, petals. There are ideally distinguished in different columns, and we have different informations for it. Then some information might be repetitive. We clean that data and we have the clean data set. After that, we do some exploratory data analysis. So what happens, this clean data, the step where we see that clean data set has happened, you have the entire data that is being available. So you go to Kaggle or any other data particular website where there is lot of data. This is the thing that has already been done. The clean data set is being created. Now it is available to the world to do exploratory data analysis. Then we apply models, and firstly we create the algorithms, then we create the model, and after that we have the entire data flow going. So this is a cycle and it repeats after a period of time. Now you might be asking that we have different kind of information that is coming in after a period of time. So how do you change it? So we start again with the phases of raw data collected. The cycle is being repeated. If any change is required, we do step by step. So if we have this particular data science process in your mind, you are good to go with the entire data science process. So keep this thing in your mind and have it ready with yourself when you are dealing with any data science project. Now comes the process of data science ingestion to visualization. So now what is the factor? We have lot of information. So if we go about any devices, now the key thing that comes to our mind is Internet of Things. So Internet of Things, what it does is, like, it carries lot of information, but this information needs to be transferred in a stream to get what we can say is real time. So this data consumption that is happening when the data is being created, we do it with the help of some tools such as Apache Kafka, RabbitMQ, or Logstash. So when we are collecting the data, we can do the transmission with help of having it real time with these tools. Now, speed layers. So some of them might be different kind of data that needs to be worked upon. So we have something called Spark Streaming, Google Data Flow, or Storm to use. But you have big data, so petabytes or terabytes of data that needs to be nurtured. We use Hadoop, Hive, or Pangool to do it. Now the serving layer. So we have to put this data into a different kind of structure where we can collect or we can make changes to it. The serving layers comes to the picture. So we have Cassandra, Druid, ElephantDB, or HBase to do this kind of information. Now, when you have this DB, we have to have some kind of visualization format that needs to be seen to get the insights into what you have done. We use a tool called d3.js. So I guess people who have worked upon JavaScript libraries, they know about d3.js. It's a very useful data visualization library. Okay, so I'm just keeping an eye on this because this is a very important stage when it comes to a data science process, because you have to collect information in any format. So the data comes in, and now we have a tool called Kafka that carries the information and takes it forward. The speed layer is like if you want to do real-time transmission of data, we use this speed layer or the batch layer. And the serving layer is like the data is coming in, we have to dump data into a place. We use a DB for that. It might be in the form of Cassandra, Druid, Elephant DB, HBase, or other options that are available. Finally, if we want to get an insight into data, we use something called d3.js to get it going. Okay. So moving on, what is machine learning? So now if we stress upon the word machine learning, you don't have to memorize all the things. Only thing that comes to your mind should be a word called algorithms. So we are applying algorithms to data, and on that data, we are getting predictions from the algorithms to get it more into a proper manner. So applying algorithms to observe data and make predictions based on the data. This is known as machine learning. So one of the most important thing when it comes to machine learning is time. So if I say that a person is doing a work and he is doing it efficiently, and if I am giving the same kind of work to machine to do, if it is not performing well, then we say that we don't need it. But we get some valuable insight into the machine and it learns on its own after a period of time. The factor that decides machine learning is good or not is time. When we are giving time and the machine learns with making less mistakes, we are doing machine learning in a proper manner. Okay. Now there are different kind of groupings when it comes to the machine learning process or the solutions. Most importantly, classification. So when it comes to classification, and this is a very important question when it comes to interview, classification, difference between classification and regression. So when we hear the word classification, you should have only one thing in your mind: discrete value. So classification means you are doing analysis or predicting a discrete value for an entity with a given set of features. And regression, you will see that it's numeric. So the keyword difference between classification and regression is classification deals with discrete value, regression deals with numeric value. Okay, and we are coming to clustering and recommendation next. So now we have some kind of data that has already been filled in. This is an example that I am trying to show, but you cannot do any analysis on this data because we have not segregated this data. So currently what we are going to see over here is the emails that are coming into our mail system. Okay, so now what you see, like the mails have been broken down into two different lines. One is the blue and one is the green line. But still we cannot say that it has been classified. Why? Because there is no segregation rule being implemented over here. Now, if I say that the green particular the rocket type of information that is there, we call it spam. Okay. Now we have a rule being set that this kind of messages that comes to us will be in the form of spam, and we can distribute among the data that has been that is being consumed into our email, and some of them that are not into the mailing process, it goes to scam. Okay. So another example of classification is sentimental analysis. So if we are using Twitter, we can say that some of the messages that comes to us, we like it or we didn't like it. So it comes in the factor of either we are liking or not it. So not liking it. So sentimental analysis is also a very important part of it. Now, multi-class classification. So multi-class classification is like we are gathering so much information into a particular place where we can have information in the form of education, sports, politics, science, and business. And one particular example of multi-class classifier would be a newspaper. A newspaper have lot of information coming in the form of different kind of sections, and it is very updated one. So, so if you think of multi-class classification, think of a newspaper. It's an example of it. Now, regression. As we have heard the word regression, it attempts to predict a real numeric value for an entity with a given set of features. Okay, so let's focus on one of the examples. We have property attributes that are associated with a place. These are price, address, type, age, parking, school, transit. Now, some of the things that are associated with price would be that it is the total square feet area, address is like the size, and then we can say that how many bathrooms are there, bedrooms, yard, pool, or fireplace. So these are the things that are coming into consideration when I'm trying to buy a property. So what happens next? We can plot it in the forms of the rupees or dollars we have and the entire square feet that we get. So when we put it in the form of curve, we get a regression line that can be created out of it. So this particular line you see is straight line, but some information that is being captured, what happens is like we collect a lot of information in between, so we cannot get the proper regression line, that is the y equal to mx plus c. We overfit the data. So overfitting is a very problematic situation when it comes to dealing data. So one example of overfitting would be like you ride on a bus, the bus is entitled to stop in a particular stoppage that has been made, but it stops in multiple places. So what happens? The destination or the journey for us is taking so much of time. So what do we say to the bus and the driver? Don't stop at places where it is unnecessary. So same thing, if we look into data itself, we can stop uh, collecting information that are not necessary for us, and definitely if we can work upon, a straight line can be created. So overfitting scenario should be avoided in data science. Okay. Now, clustering. Clustering means grouping entities with similar features. This is an example of unsupervised learning. So learning can happen in two ways, supervised and unsupervised. So clustering is an example of unsupervised learning. We have clustering of news that comes to us. Now let's look up in this particular case study where we have people who are playing games, and what we can see is on the bottom, on the x-axis itself, we have the age groups that are associated with different kind of people who are playing games. Now if we just focus along in this particular data, that is that data points that are there is no particular information that is being given to us. So this is a scenario for unsupervised learning, because we cannot have the information that is provided. We have to create certain rules that are available for us when we are dealing with this kind of data. So if we focus along, we see from the age of 15 to age of 45 or say 50, the data points are so much that we can entitle them as serious gamers. But when we move above 45, we see the number of data points are getting less. So we can term them as casual gamers. And if we go above say 65, we can say it no gamers. So we have meant, or we have dealt with a situation that we have got an insight into the data that is being created, and we can entitle them with three different circles and information being collected from the data that is being given. So at the first point there was no information about it, only a scenario was given, and we have implemented a market segmentation principle that allows us to define clustering technique. Okay, now recommendation system. Recommending an item to a user based on past behavior or preferences of similar users. So very important point is like recommendation engine is getting popular day by day. Now if you see Netflix recommendation system, it is one of the best of a kind, because if you see some movies or say web series in Netflix, it gives us a particular scenario which can be liked by you next. Okay, so let's look into a product recommendation system, how it works. You purchase a thing, and that purchase is being calculated by different kind of users that are doing some kind of um, purchase of the similar sort. So if you bought a mobile X yesterday, so if somebody or other people have also purchased the same kind of mobile, say when it was released, it would gather information from those kind of data and will give you a matrix that is very much recommended for you. So if you have purchased a mobile X yesterday, what might be the next thing? You might take a cover associated with it. So these are called as recommendation, YML. That means you may also like. Okay. So this is how a product recommendation system works. So customer call center is also a scenario of it. I'm just not touching on this. But most importantly, we get into the process of machine learning pipeline. So there might be a big challenge or a big question among people, like when you are dealing with data, what comes first? Is it the model, or which is important, the model or the machine learning algorithm? So many people will say that no, we if we have an efficient model, the system will work. But no, until and unless the machine learning algorithm is perfect for us, we cannot reach or create a good machine learning model. So the basis of data is the machine learning algorithm that is being implemented, because until and unless we have a good machine learning algorithm, we cannot get a good model out of it. So after that, we do predictions for this. So this machine learning pipeline that you see is like a perfect picture that you should keep in your mind when you're dealing with data. So you should have it, or a think process that is being created for you to work upon. Okay. Now moving along, next, applications of machine learning. So different kind of applications of machine learning are there, like fraud detection, anomaly detection, IoT analysis, movie recommendation system will also study on the use case of Netflix, like how the process works. And we have spam filtering that already we have checked upon. Natural language processing, that means somebody is speaking and we are answering on a proper manner, or say we are translating a text from English to Chinese. So natural language processing is also one of the fields of machine learning. Okay, so this is a say that is happening, like in a few years every application will use machine learning in its core. Okay, so as we have seen, or we have touched upon, we see that machine learns in two ways. One is supervised and other is unsupervised learning. Okay, so when we say supervised learning, supervised learning means we have all the information that is required for a process to continue. We train the model, we feed the model with correct answers, model learns and finally predicts. We feed the model with ground truth. That means the input and the output is already available. So if we take an example or consider an example of a supervised learning, a logic gate is a very good example where we know about the input and the output, and we apply a rule to it, and this is a perfect example of supervised learning. Now, as we have touched upon the market segmentation process, this is also how the things work, and is an example of it. Okay. Now, unsupervised learning. Data is given to the model, right models are not provided to the model makes sense of the data given to it. So if we touch upon the clustering process that has happened, and I mentioned that it was an unsupervised learning. Why? Because the information or the insight that needs to be taken up were not given. We found a process to deal with it. So that was an example of unsupervised learning. So if we just touch upon like the data is being flown in, but when we can create some clusters of this data, we get an information or valuable insight into it. So this is an example of how the unsupervised learning works. But now we have a given data set. We cannot take the entire data set and work upon it. We have to distribute among the training data set and a test data set. So we take around 80% of the data that is available for us as training data set and 20% as the test data set. Okay. So this is like a rule that is being followed. We can also have a rule that has a ratio of 70 to 32. So real life application based on machine learning. Okay. So let us go to the case study of recommendation system. So when we move into recommendation system, we know about this particular scenario of Netflix. So Netflix is very popular. Now, we as a user, when we start using Netflix, we start with some movies, they ask for recommendation, and we have the entire list created. Now let us see that there is in the Netflix itself, we have lot of amount of data that has been that is there. Now a user called Nancy joins Netflix. So how do we recommend a particular movie to Nancy? So when Nancy checks for all the fields that are available, she gives a rating of 5.04 to action, 2.5 to drama, romance it is 0.002, horror is 1.4, tragedy is 1.10. So we know about the user Nancy who has just joined. Okay. So Netflix knows about Nancy. Now there are three movies that have come in. So which movie would be recommended to Nancy? So if we just create a matrix out of it, we have to apply something called vector multiplication to get insights into which movie should be recommended to Nancy. So this matrix is being created. Now you see like there are three movies, 1, 2, and 3. What you need to do is like if we go along the action sequence, five, there is a particular fraction, a numeric fraction that is being given to action genre. So if we multiply 5.04 into 3.24, and again we segregate the drama portion that is being added. So 5.04 into 3.24, then 2.5 plus 3.44, then we go along like this. We get a score. So 26.75, and for the movie 2 it's like 56.57, and for the movie 3 it is 14.82. So the movie 2 has the highest score. So this movie would be recommended for Nancy, followed by other two that is there. So simple counting model in sentimental analysis. So we go through some of the blocks that are available. We have positive words, we have negative words. So if the number of positive words is greater than number of negative words in a blog, we say that this particular blog is very positive. Otherwise, we can say it negative. Okay. Similar as the case of linear classifier 2. Okay. So now if we move along, we have studied till this point applications of machine learning. But there is a different kind of discovery that has happened, which is known as deep learning. And deep learning is like an advanced feature of artificial intelligence that has come into the picture. So face identification is one of the example of it. So here comes some of the question that can be asked by you, like, are you curious to find how computer vision works, how they recognize a face, how they know this is a dog and not a cat? So this is a brewing domain called deep learning in machine learning world. we use neural networks. Idea comes from biology. Each layer learns something. So deep learning is a set of algorithms in machine learning that attempt to model high level abstractions in data by using architectures composed of multiple non-linear transformation. So if we see, like, this is a particular picture of a cat. Now if we process this picture in a PC, it is not able to identify like what exactly it is. So to make it identifiable, we have to break it down into different layers. So we see that there might be n layers that are there available for us, and finally we make the prediction. Now this is like the features that are needed for doing a face level extraction for a particular picture that is being there. Now we'll move to the deep learning principles and roadmap. So what we will cover today right now, after touching upon machine learning, it's like what is deep learning, what is neural network, what are fully connected neural network and convolutional neural network, and what makes it deep. Okay, so moving along, like what deep learning is good for. So if we just focus along this particular image, what we can do is in this image we can label the image. We have a person who is riding the bike. There is a motorcyclist and a bike that is associated with it. Now we do object detection. So when we do apply some kind of computer vision principles into an image, we can detect there is a person into this picture and also a motorbike he is riding. So it's able to identify this. So these are the principles of computer vision that are being applied for detection. And this particular process is also called as object detection in today's world. So semantic segmentation. So semantic segmentation allows us to differentiate between what is the exact position where the person is riding the bike and level them every pixel by pixel. Now, natural language object retrieval. So we have created a system and we ask, like, who is the left person in the particular image. It is being identified in this way. So if we are making a system like that is using multiple things to work upon, we can also come up with object retrieval process. So we query about the man from far right, it would do analysis of the picture and it gives the information. So this is the way it works. Now, visual and textual question answering. So we are covering the deep learning world. Now, what are the use cases of it? Now, we can say that if we are applying a particular uh, principle or say segmentation into it, we can directly see from the images, like if the particular image is of a bus, we use a segmentation and we get the answer as blue. Okay. Now, speech recognition. Speech recognition is like the basis of our startup too. We are working on different kind of principles like neural voice cloning, and then we have an product that converts a particular voice in real time. So, speech recognition is also a very important part when we are trying to convert from one language to another in runtime. Okay. So supervised learning. Now, if we just focus along this particular image that is being given, here comes a scenario where we have to find out how the data is being worked upon and how we can figure out like what are the things that are there in a particular snapshot. If we have a camera fitted in a particular place and we are analyzing the data, what we can say is like if we have created neural network, as you see from this particular option over here, and I say that this particular person is a cyclist, it goes to the neural network and identifies like this particular person is a cyclist. So this information that are stored in the nodes of neural networks carries lot of proper information that can be worked upon and can be used for identifiable process. So we can say that from this neural network it was able to find out 90% 90% of this particular box that is being created is a person, and 80% 8% would be it's a traffic light. Now we have created a model. Now this model needs to be implemented. So this idea comes to the facts like inference. We will talk about some of the tools like Intel OpenVINO toolkit that allows us to complete the entire process in one particular engulf that we have. So when we created the model and we have implemented the model in, say, a railway station, and we are trying to find out who are the what are the things that have come to a railway station, we can say that this particular image that is being shown over here, or it's, if it's a live feed also, this is a person that we have. Okay. So now we will talk about neural networks. So neural networks, when we study upon, are just a basis of how a particular neuron is being created. That is coming from the word biological neuron that we have. Okay. So now, if we study neural network, before that, we should have a proper understanding of what is how we apply neural networks in machine learning and deep learning. So the perfect identifiable process between a machine learning neural network and also a deep learning neural network is that if there are hidden layers that are more than 2 level deep, we directly coin it as deep learning network. If it is still two layered, we call it as a machine learning process. So examples might be that we already know of. Like if we consider this deep learning process, we have a picture of a cat, dog. There are different kind of topologies that are being associated to identify this particular thing. But when it comes to, say, some of the clustering process, we have one or two hidden layers itself. Now comes the story of neural network. So when we are covering a neural network, it generally tells us that we are simulating a brain function. Artificial neuron is the basic building block of it. So taking n inputs, as we see, like over here, like we have inputs that are coming in with weights associated with it, and a particular being threshold value is being kept until and unless the neuron will not get triggered. So some of the different kind of activation are required to propel the network forward. So these are sigmoid, tanh, or say step function, or tanh that we have. Okay. Now fully connected neural network. So if we see that in this particular neural network that is being created, we have a node that is being connected to every other node in the next particular layer itself. So every node is connected to alternate layer in the first level itself. So information carried upon from one layer to another, it's like tedious and time consuming. So fully connected neural network is each neuron is connected to every neuron in the previous layer. Every connection has a separate weight, not optimal for detecting features, computationally intensive, heavy memory usage. Now, convolution neural network. We saw that fully connected neural network, every particular node is associated in the previous node, and all of them are connected in to get the information. But in convolution neural network, what we create is like we have an information that needs to be carried upon to the next layer. We do not take the entire picture set that is available. We have a kernel or an information that needs to be identified to find out what is there in this particular image, and this is being projected in the next layer. From there it is being taken up and then carried upon in the next layer. So one particular information is being created. The same thing is being shown over here, like one feature is being extracted and it is being projected in the next particular layer. So each neuron connected to a small set of nearby neurons in the previous layer, use same sets of weights for each neuron, ideal for spatial feature recognition, example image recognition, cheaper on resources due to fewer connections. Okay. So how deep are deep neural networks? So if we have an image, the first thing that comes to our mind is like that image, when we are trying to make it into a role of deep neural network, in the first level of the abstraction itself, how much or how it is being distributed. So if we think of an image, we say that the image is built upon a red, green, and a blue scale. So in the first level itself, there are three levels of abstraction. So if we break it down, the entire scenario would be in the form of neural network that is being shown over here. Okay. Now, convolution neural network for image recognition. These are the important points that are there for convolution neural network. That is the input that is being given. It might be 32 into 32 into 33. That is the with that holds the information. Now we have the pixels that are being associated with it. That is in the form of RGB. Convolutions are the informations or the layers being created in the step-by-step process to get more insights into the data, and we are applying an activation function, say ReLU. ReLU layer will apply an element-wise activation function such as max0 to a particular value that is being there. So it ranges between a 0 to a particular range that comes into the mind. This leaves the size of the volume in change. So pooling is something that is being informed, or the information is being created. So let's take an example of Rubik cube. So when we play the Rubik cube, it's very difficult to solve that 3 into 3 problem. What we do is like we break the cube into different sub problems. That is, it comes in the scenario of dynamic programming, and there are certain rules to solve it. So there are sub problems that are needed. So in the same way, pooling breaks down the entire information that is there and solve it into sub problems. And like we have like a 4 box, in that we have a maximum value of 1. We take this and we carry it along in the next process. And if we are gathering information, or say we are talking about fully connected layer, yes, fully connected layer is also required for convolution neural network for image recognition. So the same thing, if we take upon an example of digit recognition, we have small kernels being used and being carried upon in the next layers, and we have the subsampling process so that we get the final output that is there. Now this is also a process of like image recognition. If we have time, we can study AlexNet or say GoogleNet, but later on, if we have more time, we can discuss on this. Okay, so these are the different kind of topologies that are getting popularity nowadays for deep neural network. One is AlexNet, GoogleNet, for convolutions that are being created. So we have touched upon major parts on machine learning process. Now you might be asking, like, what are the tools that are there available for us to work upon? So I will share some of the open source tool that is available. Now, if we just touch upon, or if you want to get started today on computer vision principles or rules, or like different kind of things, we have a tool called OpenVINO toolkit. So what exactly is OpenVINO? We have a complete set of tools that are associated with it. So if we can see, or if we can manage upon, like you have this deep learning optimization process, learning deployment, and we have in this particular page that we have, if you can go along, you will see that you have the process of learning it and how it can be applied. So without further ado, I will just share a small video of 1 minute, and we can see like how the entire OpenVINO network works.
We live in a world where a picture is worth 1,000 words. Or, if you're a developer, it's worth a ton of data. Visual information is something humans take for granted. And for computers, the gift of sight with visual recognition and understanding is opening up exciting opportunities, new usages, and advanced capabilities, even at the edge. Now, developers and data scientists can build smart video and vision solutions more easily. It's no longer the domain of a few select experts. The Open Visual Inference and Neural Network Optimization Toolkit, or OpenVINO, helps developers build high-performance computer vision applications with deep learning inference that fuel artificial intelligence from edge to cloud. Easily develop solutions that achieve great performance across Intel processors and accelerators. Use the toolkit to optimize applications for numerous usages: digital surveillance, retail, manufacturing, smart cities, healthcare, office automation, transportation, and much more. Optimizations with the OpenVINO toolkit can increase deep learning workload performance up to 19 times higher using Intel computer vision accelerators compared to public deep learning models. So what tools are inside? The OpenVINO toolkit includes the Intel Deep Learning Deployment Toolkit with a model optimizer and inference engine that help integrate high-performance deep learning inference. Save significant time and resources with the included pre-trained models and code samples. You can also be confident with your deployment, as the OpenVINO toolkit was tested and validated on more than 100 public and custom models. Plus, you'll save time building key application features with computer vision libraries, including optimized OpenCV. A vast assortment of code samples helps you get started. The OpenVINO toolkit also includes other tools and capabilities, so you can build new features into your application, gain even greater performance, or even optimize for certain hardware. It's easy to get up to speed with the OpenVINO toolkit. Check out our free webinars, how-tos, quick tips, and more at techdecoded.intel.io. Empower your applications with new levels of visual intelligence. Download the OpenVINO toolkit for free today.
Okay, so that was a small introduction into OpenVINO. You can just go to this particular website and get the information, and it's completely free. And one of the tools that I've already mentioned, like OpenVINO toolkit, why I'm emphasizing on this is like it's a complete computer vision solution with a lot of examples that are there, and you can get started with it completely free. Now you might be asking questions like, if I want to try out FPGAs, or if I want to try out different graphics card, that is the GPU unit that's available, how you get started. So there is also something called the One API based toolkit that is available. You go to this particular place where you have the One API toolkit. Now if you want to work on the dev cloud itself, it's completely free right now. You can get started of like 45 days access. And if we just focus along on the left hand side, you will see like you can do your calculations using Xeon scalable processors. We have this Intel Iris Max GPU that is available, toolkits that are mentioned. You have the beta tools available. You don't have to install anything on your computer. Just give your information over here, head forward to dev cloud, and you are good to go with the tools that I have already mentioned. So One API and OpenVINO toolkit, it's there here, completely free, and you can just get started with it. Okay, so moving on, like there might be some questions like, I do see machine learning in action, but I want to simulate certain things. So when we distinguish between different kind of fields or an umbrella of an AI, we see that it's being distributed in the form of machine learning, deep learning, and also a very important branch that is getting popularity nowadays, which we called as the reinforcement learning. So you might be familiar with a video that has come up on 31st from Boston Dynamics, where you see robot doing a lot of stuffs or like dance moves that are being created. So simulations in this form is different. So exactly when we differentiate between machine learning, deep learning, and reinforcement learning, we see that machine learning is completely based on the data that is being available. But when we move into deep learning, it's more on the images or different kind of say speech synthesis data that is huge in size and more than 3 layers deep. We directly call it as deep learning. But now, what is reinforcement learning? So reinforcement learning comes in the form of studies of different kind of environments, simulations. So we are not directly involving data in this, we are involving simulations. So when it comes to the world of simulations, you can give it a try using one of the toolkit that is there available for free, which is called as Unity ML agents, and it gets integrated directly into a game engine called as Unity. So what you can do is like you have this particular scenario where you have the scenes. Now when we move along with the different kind of information that is being collected over here, you have a complete environment that is being created over here. Now you might be asking like, what are the things that are there in this particular uh, the toolkit? So we have a Python library that gets engulfed into this Unity framework and does the training for you. A model is being created. That model can be utilized in the environment that you are working. So some of the simulated or already pre-built model are there. If we just focus along, this is a 3D ball model that is there. You have all the things or the information that is being created in a neural network format in ONNX model that is being created, and you can take it forward with different kind of frameworks like TensorFlow models are being created when you train it. So you can see. Now you might be saying like asking what exactly it does. So let me just play this application or the environment that is being created, and you can just see like what exactly it does. So just bear with me, it would take some time to come up. So if you focus along on this particular information or the objects that are being shown, you see there is a ball balancing act happening on these objects on the objects that are available, and they are trying to balance the ball that is being created. Now you can modify this example in your wish or in your liking with different kind of balls and try the machine learning process on your own, give it a complete tweak, and then you have a different scenario out of it. Okay, so these are the ways we can implement machine learning, or say the applications of AI to see how it works. So because reinforcement learning is completely on trials and learning process, it's gaining popularity for different kind of robots or then AI based advanced application that we are working upon. So that would be it from my side, touching on, because the time was very less, and I thought about like what are the things that can be completely engulfed in 1 hour time and can be showcased. But later on also, if we just have more time or say more constant wise, if we are having breakout sessions in one upon one, we can do more sessions like this, because for the last period of like 1.5 years or 2 years before the pandemic started, uh, I was involved in artificial intelligence sessions across all of the major engineering colleges in IITs, and I took sessions. So if any kind of information or any kind of flow of uh, artificial intelligence work is required, you can come back to me. I have a YouTube channel too, and we have this complete me groups that are there, because Tushar has also asked me to take the sessions. We can continue like this, and we can do a lot of insight into it. So thank you all for being with me. I guess this might have given you some kind of information, and if we have any queries, you can ask. Over to you, Tushar.
Uh, Thanks a lot, Abhishek. It was indeed a great session and had a lot to learn. So now we are open for the questions. So if you guys having any question, please feel free to write down in the chat box. So we have from Janish Shah. Do we need to divide the data into validation data set?
Okay, so now when you are talking in terms of validating a particular kind of data, so first of all, you need to identify like what exactly you are trying to do. Is it like mandatory to do the validation, or is it like we are just having a particular information that can be carried upon? So let me just give you a scenario. Like we are identifying some kind of plant disease that are there. So there are different kind of diseases in plants. In that case, we have to validate the data, because uh, until and unless a big data chunk is being created to identify a machine learning process, it will not give us good results. So for that, you have to at times validate the data.
Okay. Hope that will his answer. So the next question is, which model is best for text recognition with good accuracy?
Okay, so now the most important thing that you can work upon is the Mozilla's the deep learning data set that is there for text identification. We have Google also that have WaveNet for their text identification process. That's very much powerful.
Okay, thank you, and thanks Abhishek for answering some questions. So there is one question from mind also. As all of our participants are not live right now, so
Mhm.
surely we will have the full access of this recording on our YouTube channel.
Mhm.
So as you know that we are also organizing hackathon in our upcoming days. So is there anything would you like to suggest them?
Okay, so when you're creating a product or we have a hackathon in mind, one of the important thing is like when you are presenting the entire application to the final set of people that we have to have a very good video, one presentation, and also a storytelling that helps us. Because the most important part when you're doing with hackathon is like what problem statement you are trying to solve and what is the solution and how good it is. So that would be very helpful.
Thanks, Abhishek. And there is a one last question from Keith is asking why do we need CNN?
Okay, so convolution neural networks, as we know, the self-driving mechanism. We talk about self-driving a lot of days now nowadays itself. So each and every information that is being carried upon is a small chunk that can be broken down. So why this CNN came into being was because fully connected neural network was very much compute intensive. So deep learning enthusiasts or the scientists that they created something called convolution neural network, so that the information can be carried upon in a small factor to the next layer. So we need convolution neural network.
So thank you, Abhishek. These were some very valuable suggestion. It would be great help for the hackers. And thanks once again for joining us today.
Thank you all. Bye bye.
Bye. So uh, for all, do fill the feedback shared in the chat section, and it will be used to assign the certificate for this session. It will be open for only 15 minutes and won't be reopened again. Thanks a lot everyone for joining in today. Keep an eye on our social media for next session and don't forget to subscribe the channel so that you can get the updates for all the workshop coming up ahead. Stay tuned. Hope to see you in the next session. Stay safe. Take care. Bye.